Okay, Trig, I forgot to warn you that I'm going to be gone today. I had to leave for a doctor's appointment, so we will finish presenting all your stuff tomorrow in class, but 5-1, we'll go through these notes today, and we'll see where we get. So 5-1, or chapter 5, is all about square roots and cubic roots and those types of things, and exponents, and eventually in chapter 5 we start getting into logarithms. And those, I don't know if you guys are going to be taking the ACT here pretty soon. They do have a lot of exponents and logarithms and stuff on the ACT, so this is going to be really beneficial for you. But it's good to review like exponents and those types of things before we get to that. One thing that I know for sure that the ACT really tests you on, and I talk about this in algebra and I talk about this in like every class, is like whether you know the difference between x squared times x cubed and x squared cubed. In one of those you multiply, and one of those you add. And most of you guys know this should be x to the 5th power. This is where you're adding these. And this is where it should be x to the 6th power. This is where you're multiplying, okay? Now that is pretty straight, cut forward, like pretty easy to figure out. But then when you get like problems like we're going to eventually do like stuff like this, right? And you are like multiplying this through, and then it gets really confusing because now you have fractions in your exponents and you're like, oh crap, do I add or do I multiply, right? Think back to which one of these you're doing up here, and that can help you, okay? Don't let the fractions confuse you. Are you adding or are you multiplying, okay? So always come back to this example, even if you have ugly exponents, always come back to that example to figure out, are you adding or are you multiplying the exponents, okay? So when we're talking about roots, let's see. I'm going to skip that graph because it's a little confusing. The one thing that I want you to remember from this box right here is that whenever you have square roots or cubic roots or anything like that, you can always write the exponent as a fraction. So over here, for example, like x, the square root of x can be written as x to the 1/2 power. Okay, the cubic root of x can be written as x to the 1/3 power. All right, then what do you do if it's like the 4th root of x to the 3rd power, right? Okay, well, we know that this number becomes the bottom of my fraction, right? Well, this is the bottom of my fraction, this is the top of my fraction, so this is x to the 3/4 power, right? Okay, let's do one more. Let's do 8. The 8th root of x to the, I really hope they don't ever give us these, the 8th root of x to the 5th power, right, would be x to the 5/8, okay? The root gives you the bottom of the fraction, and the power inside gives you the top half of the fraction. Now, I want you to also remember that this means the same thing as this, okay? So it does not matter if the 5 is underneath of the root or the 5 is on the outside of the root. Those mean the same thing. They're interchangeable. So that 5 can go either inside with the x or on the outside. It doesn't matter which. It doesn't matter if you apply the root or apply the exponent first. It doesn't matter which one. Those are interchangeable, okay? So whatever you prefer to do, okay? All right, example 1, simplify each expression. When it says simplify, that means don't use a calculator and give me a decimal number, okay? The square root of 8 and the square root of 12, what they're wanting you to do there is multiply those together. That's the square root of 96, but don't leave it because it can be broken down. 96. I know that 96, that 4 goes into 96, and it goes in there 24 times. But 24 can be broken down some more, so we got to use a bigger number when we're breaking down 96. Let's do 16. Does 16 go into 96? Let's see. Sorry, I have a dumb calculator. 16 and 6. 6 cannot be broken down anymore, so we do 16 and 6. The square root of 16 is 4. The square root of 6 just stays, so it's 4 squared root of 6 is what it will look like when it's broken down, okay? So you want to use the largest number possible inside of that bubble when you're breaking stuff down. So we tried 4 to begin with, but we saw something could be bigger, okay? Let's go to this one right here. Okay, this one was multiplying. You can multiply any numbers together even if they don't have the same base underneath. When you are adding and subtracting, this one's subtract. You cannot do it unless these inside bases are the same. Now, can we change them to be the same? Probably. So if we break 12 down, this is 4 and 3, right? and the square root of 4 and the square root of 3. Square root of 4 is 2, square root of 3 just stays, so this is 2 square roots of 3. Then we are subtracting. Let's break down 75. I know 25 goes in there 3 times, so the square root of 25 is 5, and the square root of 3 just stays, the square root of 3. Now, they're both square roots of 3, so 2 square roots of 3 minus 5 square roots of 3, all you do is like the 2 minus 5, and that will be negative 3, and the square root of 3 just stays on the end. This would be like, kind of like saying 2x minus 5x, right, is negative 3x, okay? The bases on the back just stay the same, right? So negative 3 square roots of 3, that's what we get for an answer, okay? All right, let's go on to this next one. Okay, this one is a cubic root, okay? And we have lots of junk going on underneath of here, okay? So what we're going to do is we are going to break it down, and we're going to do the cubic root of 8. And then we're going to do the cubic root of x to the 6th power over here. Then we're going to do the cubic root of y to the 4th power over here, and we're going to slam it all back together when we're done doing the individual pieces, okay? So we're going to look at trying to do the stuff that comes out nicely, like the cubic root of 8. That means what do you take times itself 3 times to get 8? And it actually comes out as 2 perfectly, right? Like 2 times 2 times 2 is 8. So the cubic root of 8 is 2. That comes out nicely, okay? This one is the cubic root of x to the 6th power. So is there something you can take times itself 3 times to get x to the 6th power, okay? And that actually comes out as x to the 2nd power, right? Like x squared times x squared times x squared, that's x to the 6th, okay? So that one comes out perfectly, all right? Now this last one, is there something you can take times itself 3 times to get y to the 4th power? That's where we get stuck and it doesn't work. So what we're going to do is we're going to break it down, and we do it just like we would do these guys up here where it doesn't break down nicely, okay? So I am going to do this. The cubic root, if I'm taking the cubic root, I'm going to start with y to the 3rd power because I can take the cubic root of y to the 3rd power, but that means I need a y to the 1st power over here to make a total of 4 of them, okay? Now, I take the cubic root of this, and I take the cubic root of this, right? The cubic root of y to the 3rd power is just y. I'm running out of room. Y, and the cubic root of y I can't do, so I just leave it the cubic root of y. So this one right here, I'm gonna use a different color. This one right here, the cubic root of y to the 3rd power just became y, or y to the 1st if you need a y to the 1st. And then this one did not come out nicely, okay? So now when we slam it all back together, I've got a 2 and an x squared and a y on the outside, so 2x squared y. And then on the inside, what I have left is the cubic root of y. Okay, so that's what all I have as my final answer, okay? All right, now, to me, technically, this thing looks uglier than what I had to start with, but this is considered like improper, and this one is considered to be proper form, okay? Because it's more simplified. Everything's broken down underneath, okay? D. All right, let's see D. We are foiling. Okay, where it says where C is greater than 0. Okay, don't get bogged down by that. What they're saying right here is C has to be a number greater than 0, which means we're not dealing with i's at all, right? We're not dealing with negatives inside of a square root. So that's not meant to confuse you. That's actually meant to be helpful so that we know we're not dealing with any i's here, okay? So I can just FOIL straight and everything looks fine, okay? All right, so we're just going to FOIL. 5 times 5 is 25. 5 times negative square root of c is negative 5 square roots of c, right? The 5 is on the outside, the c is on the inside. They can't touch each other, so we do negative 5 square roots of c. These two, if I multiply, that would be a positive 5 square roots of c. And then if I multiply these together, positive times a negative is going to be a negative. And the square root of c times the square root of c, okay, if it helps you to think about it this way, is the square root of c to the 2nd power. But the square root of c squared is just c, right? Okay, we've done it before where you like take the square root of 2 times the square root of 2 is just 2. The square root of 7 times the square root of 7 is just 7. The square root of 100 times the square root of 100 is just 100. If you take the square root times itself, it ends up just like popping out of there. And the reason why is because there's 2 of them and you're taking a square root. So it's just that, okay? All right, now these two are going to cancel out. So I really have 25 minus c, and that's all I have. Okay, now these middle 2 pieces canceled because these 2 things are special. Okay, those two little things that we had in bubbles are called conjugates. Okay, we've talked about that before, conjugates, and because they're conjugates, those middle two terms are going to cancel out with each other. So we end up with kind of a nice answer-ish. You know, it's not too bad, okay? Only because those two things are conjugates, okay? All right, here we go. Use a calculator to approximate each expression. So this is one where you are allowed to use a calculator, and it says to the nearest 10,000th. Okay, how many decimal places is this? Okay, here's my decimal place. If I have a spot here, this is the tens, or tenth. This is the hundredth. This is the thousandth. And this is the 10,000th. Okay, 10, T-T-T-H, I don't know, 10,000th, okay? So that means 4 decimal places, 10th, 100th, 1000th, 10,000th. So 4 decimal places is what they want us to do, okay? In your calculator, you might not be able to, or you might not know how to type this in. You can do a couple different things. So you can do 40, and you do the caret button, and then you can do parentheses and do 1/5, like that, or one, if you don't want to do 1/5, you can do 1 divided by 5, like that, and that will give you 40 to the 1/5 power. Also, you can hit, so 40 to the 1/5 power is technically like the 5th root of 40, okay? So here's how you do this. If you want to type it in as the 5th root of 40, you go 5, you hit the 5 on the main screen, okay? And then you go to math. You go to the math button. The math button is going to be like in the same column as like the y equals button, but you go down like all the way down like to math. Math is, I don't know, a couple keys down, maybe like the third one down. Okay, you go to the math button, and then it should have a button under math that has, it looks like this, okay? That's going to tell you a root, okay? The cubic root is like right above it. So it's 5, and then you'll hit this button, and it'll take you back to the main screen, and then you'll put 40 underneath of there. So it'll be 5, the 5th root of 40, and it should be able to type that in for you. I'm going to see if I can do it on my stupid phone calculator, because that's all I have. Oh, I don't know. Yeah, it did work. I think it worked. 1.0411, maybe? 5th root of 40. No, that's not right, because the 5th root of 32, I'm pretty sure, is 2. I don't think that did it right. I don't know. What the answer is. Maybe it is right. Let's see. 2 to the 5th power. No, that's not right. How do I do it on my stupid phone calculator? I don't know. 40 to the 1 divided by 5. I don't know. I don't know how to do it. 40 root 5. There we go. I think this is right. 2.0913, I think, is how to do it. I think that's the 5th root of 40. Okay? Don't quote me on that. I could be wrong. I think that's right. 2.0913. Okay, this one's the same thing. This is the 11th root of 225. Okay, or 225 to the 1/11th power. So again, you can use either one of those methods. You can do the caret button and do 1/11th power, or you can do 11 math and then that button that looks like this. And that will do it. Let me see if I can do it. 225 to the 11th power, or the 11th root. And I don't know if this is right, 6362. I don't know off the top of my head what the 11th root should be, but that sounds maybe like it's okay. 1.6362 if you round to 4 decimal places. Okay, so that's how you will type those numbers in. Okay, good. All right, let's go to the back side. Let's do a couple of these, and I'm not going to do all of these. We're going to do like 1 or 2, and we're going to go through these laws first. Okay, so we'll do these laws, and then maybe we'll do like A and B. How about there? And then we'll stop. Okay. All right. So these laws right here says this is like this is my x to the second times x to the third. And this is where you add the exponent. So this is x to the 5th. Okay. This is my x to the second and then to the third, which is x to the 6th power. This is where you multiply. So this is my multiplication. This is when you add, okay? When you are dividing, this is when you subtract the exponents, okay? So if I had like x to the, let's say x to the 5th over x to the 2nd, I would subtract those two, and that would be x to the 3rd, right? Like that makes sense that there's 2 on the bottom, 5 on the top, then that means I have 3 because 5 minus 2 is 3. And that's how that works. So subtracting those, that's the rule for that one, okay? All right, let's go over here to number 4. If you have an exponent outside here, like xy to the 3rd power, that means x to the 3rd power and y to the 3rd power, okay? I distribute that r through. Same thing if I have division. So if I have x over y to the 3rd power, that's x to the 3rd power on the top and y to the 3rd power on the bottom. So those are just the rules of distributing that exponent, okay? All right, here's the big one that people forget. In addition to this one that people forget, x, like the square root of x, means x to the 1/2 power. Remember that, don't forget that. Or like the cubic root of x, people always forget this rule. That's how that works. People forget this one also, okay? If you have a negative exponent, then that means you can put it down to the denominator and it becomes a positive exponent, okay? My calc kids, we're doing this right now when we're simplifying before we take the derivative, okay? You're moving those exponents around, positive, negative, okay? This one, like let's say I have x to the negative 3rd power. As a fraction, I can put that over 1, and then what I can do to make that positive is it has to go down below. So this would be 1 over x to the positive 3rd power. Now, what happens if I have like, let's say I have an example of like 4 over x to the negative 5th power, right? To make that positive, I can move it up as well, right? And the 4 just stays. He's just going to chill out. So he's going to be 4x to the positive 5th power over 1. And you really don't need a 1 if it's on the bottom, right? So if I move him up to the top, he'll just be 4x to the 5th power, okay? So just examples. When you have negative exponents, you can move them top and bottom, and that's how that transitions, okay? All right, so let's do a couple of these, and then we will be done. All right. Write the expression using only positive exponents. So we have a negative one right here that we're going to have to fix here in a little bit, okay? But there are 3 pieces here. There's an 8, which is a constant, an r to some power, which is really ugly, and an s to some power, which is kind of ugly. And we're taking all of that to the 2/3 power. So the way that this works is that we have to take everything and distribute it to the 2/3 power, okay? So I will have 8 to the 2/3 power, okay? I will have r to the 3/4 power, that to the 2/3 power, and I will have s to the negative 3rd power to the 2/3 power, okay? If you don't like to write it out like that, and you want to just do the math already in your head, go for it. You can skip this step, okay? All right, I'm going to let 8 to the 2/3 power chill, but then this means I multiply those, okay? All right, when I multiply 3/4 and 2/3, the 3's can cancel, and the 2's and the 4 can reduce. So this is r to the 1/2 power. Okay, I hope that made sense. 3/4 and 2/3. Or you can do 3 times 2 is 6, and 4 times 3 is 12. But 6 over 12 is 1/2. So whichever way you want to reduce it, I don't care. S, this is 3 over 1. Again, the 3's can cancel. So this would be just to the negative 2 power. Okay, so that's how that works out. Okay, good. Now we have to fix it. All right, so 8 to the 2/3 power. All right, 8 to the 2/3 power. I'm going to do this off to the side. 8 to the 2/3 power means the cubic root of 8 squared, okay? And I can either put the square down here or I can put the square up here. I'm going to put the square up there because I know that the cubic root of 8 comes down really nicely, and that's 2, and 2 squared is 4, okay? Now, you could have done it as 8 squared first, and that's 64, and then what times itself 3 times will give you 64. That's also 4. So it doesn't matter which way you think of it, but here, if I do the square last, I have to deal with smaller numbers, okay? So 8 to the 2/3 power is just 4, okay? R to the 1/2 power just means the square root of r, so I'm going to put him underneath of a square root, and then s to the negative 2 needs to go to the bottom, so he goes underneath as s squared, and this is simplified, okay? All right, if that was too fast, go back and watch it again, okay? And why don't we stop there, okay? Instead of doing B, we'll save B for tomorrow. So There you go. That gets you through A. If any of those examples I went through too fast, please pause and go back to them. But also, you guys should have maybe some time to do some things. So these exercises 1 through 4 evaluate without using a calculator. This is just like doing the math in your head. So some of these, I mean, you can write out 27 to the 4/3 power is the cubic root of 27, and then to the 4th. Okay, figure out what that is in your head. Okay, you can do it, I promise. Some of these other ones you can do. We've done problems like 5 and 6 and 7 and 8. You can do those. Okay, so attempt those for tomorrow, and then we will finish up notes tomorrow. Okay, and presentations. Goodbye.